In this video, we're going to explore the Normal Distribution app. There's 3 components to this app, including the Explore function, which shows you what the normal distribution looks like based on a specific mean and standard deviation. We have the Find Probability app, which is probably what we'll be using most often for. That allows us to find a probability of something above, below, or perhaps even in between values. And then there's also the Find Percentile and Quantile portion of the app. So this would be if you're looking to find the kind of reverse route, right? If you're looking for that percentile that a piece of data would fall into. So under Explore, I'm just going to play around with this and show you what happens if we move these sliders. So this allows us to shift the mean around. And then you can see, if we also shift our standard deviation, how the graph changes a little bit. So let me go ahead and leave the mean at 0 and just modify the standard deviation. So you can see that it either perks up or the normal distribution kind of flattens out. So the way that this defaults when it starts in with a mean of 0 and standard deviation of 1 is representing the standard normal distribution. So standard normal distribution, you may recall from class, is what you're basing your z-scores off of. So again, standard normal, that means that everything you do, you're scaling it back to those standard normal values, or z-scores if you will. And that's what's going to allow us to also find the probability of things. If you were doing this manually with the find probability, you probably would have started off by finding a z-score. And then you could, if you're not using technology, you could use a z-score table basically to find those given probabilities. What the app does is it asks you for your mean, standard deviation, and then what value are you looking for? And it's going to then give you the probability based on that value. The picture also shows you exactly what you're typing in. So if I'm looking for lower tail, you'll notice that the shaded region is darker on the left because lower tail represents to the left. If I want the upper tail, let me switch this around. You'll notice that the darker region is now shaded to the right of that x value. And that's telling us that that's the probability it's giving us. So one thing that we always have to remember is when you're dealing with continuous probability distributions, the normal distribution is one of those, that the probability is always going to be represented by the area under the curve. So if you know the area under the curve, the normal distribution in this case, that shaded region, that means you found the probability. So again, that shaded region should match what it is you're looking for. If you wanted an interval between values, then you would just specify what values you're looking for. So maybe I want this between 1.2 and 2.2. So you'll notice that now our shaded region, it's to the right of the mean between 1.2 and 2.2, and it's visually showing us that value and then what that probability is. So as a percentage, it's 10.12%. As a probability, it would be 0.1012. On the other hand, if you want to find the percentile, so in other words, working backwards, that means that if you have a mean and standard deviation, you can find what that x value will be based off of what percentage you want. So let's say I'm going to leave my mean and standard deviation at 0 and 1 for now. If you had a different set of data, then you would want to make sure to change those. What if I want, let's do upper tail. So what if I want this tail region to represent only 1%, and they specify to use percentage? That means that the x value associated with that would be 2.326. Later in the course, when you're taking statistics and you get into things like confidence intervals and hypothesis testing, this is also a way that you could calculate critical values, though at this point, again, you're using them just to calculate percentile values. So in this case, 1% in the upper tail is the 99th percentile because it's based off of what's to the left. If you wanted, let's say, a lower tail, and you want this probability in the lower tail to be, let's say, 2%, now you'll see that that percentage, that's the second percentile, it's being represented by that shaded region, and that would be an x value of negative 2.054. Thanks for watching.